Okay, so as the title suggests, today we're going to look at finding the area of a triangle. Now, it's not the first time that you've ever met this. You met this in primary school and then again in secondary school. I suppose in primary school you dealt mainly with the right angle triangles, and we might have been told that the base here was 10 and the height here was 5, and you had to find the area of the triangle. And you know yourself that to find the area of a triangle back in primary school, it was base times height all over 2. Then you came to secondary school and we said, well, that is kind of true, but in actual fact, it's the base times the perpendicular height. So we introduced this idea that in the right angle triangle, this was actually the perpendicular height. And now we had to find the perpendicular height of isosceles triangles and equilateral triangles and so on. And we might have used base times perpendicular height all over 2 to find the area of a triangle. And then you might have even used a little bit of Pythagoras' theorem to try and help you find out that as well. We're going to look at another way to find the area of the triangle, and this time is if the area of the triangle is drawn on a coordinate plane. Okay, so I have a coordinate plane here and I am going to find the area of the triangle, and I'm going to place 3 points and connect them up. So you might say to yourself, okay, well, I could still find the base times perpendicular height of this triangle here. I could say to myself, okay, well, to find the base, I could choose maybe this here to be my base. And so to find that, I'd need my distance formula. I could find the distance from A to B. I could then find the midpoint from A to B and use that part then to find the perpendicular height from the midpoint up to C, find the length of that, and then I would have the base times the perpendicular height all divided by 2 to find the area of a triangle. Now, there's a lot of work involved in that, so you'll be happy to know there is a much easier way when dealing with finding the area of a triangle on a plane. So you can see here I've given you the formula, and it is half, and this line here stands for the modulus, and the modulus just means whatever number you have in here always has to be a positive. And the reason for that is obviously you could never get the area of something and it be a negative, so to just be aware of what they actually stand for. So it's a half and it's x1 y2, so obviously they're right beside each other, that means multiply, minus x2 y1. And we can see here we have 3 points. So if I was to label the points, and I'm just going to assume all of my numbers here are 1 units. So this would be the point 0, 0. I go along as far as 1, up as far as 3, so that's the point 1, 3. And then this last one here is along as far as 4, up as far as 1, so 4, 1. And what I might do is I might name one x1, y1. x2, y2, and I have this third one which is just the zeros, which leaves me happy enough. I have everything I need to fill out the formula. So in this case I'd go, it is half of x1, which is 1, y2, remember that means multiply, minus x2, which is 4, times y1, which is 3. And so that would become half, 1 times 1 is 1, minus 12. So in this case, I'm going to get half of minus 11. But remember, the modulus means it can only ever be positive. So in this case, it would be half of 11. And you might say the area of that is 10.5. And because we don't actually know whether it's centimetres, meters, we'll just say units, and we'll say units squared. All right. Finding the area of a triangle when given on a coordinate plane, not too bad. We just need an x1, a y1, an x2 and a y2. Okay, so here we're given a triangle and the 3 points, I'm just going to make them nice and clear for you because I know the last part of that diagram isn't very clear. We might have 1 and 3. The next point up here would be 3 and 1, 2, 3, 4, 5, 6, 7, so 3 and 7. And let's say the last part is just here, so we've got 8 and 5. Okay, and we're again asked to find the area of the triangle. I suppose step 1 would be always write down your formula. Okay, and then step 2 would obviously be label your points. Now at this point I don't have any that's 0, 0. So you can see here, I could call this one x1, y1, this one x2, y2, and this one x3, y3, but that's not going to help me because it's not at 0, 0. So, and I can't leave out 2 points, okay? So what I'm going to do here, guys, is I'm actually going to move the triangle. I'm going to move it so that one of the points here is 0, 0. And how I'm going to do that is by translation. Okay, so remember, translation is when we move a certain line or a certain object on the plane. And what I'm going to do is I'm actually going to move this triangle the whole way down so that one of the points is at 0, 0. Now, obviously, what that will mean is it will mean that all of my points have actually changed now. Now, it's fair enough, it's easy enough to do it on a diagram, but I'm going to show you how you would do it in an exam where you can't move something physically. So originally my points were 1 and 3, 3 and 7, 8 and 5. And what I'm going to do is I'm going to bring any of those points to 0. I'm going to start with the 1 and 3 and I'm going to bring it, as I would in this diagram, down to the origin. So what I initially do is I bring the point 1 and 3, and you can bring any of the points, it doesn't matter, I've just chosen that one, to 0, 0. Let's have a look at the translation and see what did I do. So I actually moved the x value by a -1, and I moved the y value by a -3. And what I'm going to do here, guys, is I'm going to proceed and do the exact same in the other two instances. So my 3 will go down by -1, which will be 2. My 7 will go down with 3, which is 4. My 8 will become a 7, and my 5 will become a 2. And so what I'm left with here now, at this point, is 3 points, okay? Remember, I have moved the triangle. I have not changed the size of the triangle in any way, so the area is still the same. I can now apply my formula by labeling this one x1, y1, x2, y2, because I now have one point at 0, 0, and I follow on through and do my formula as normal. So it is a half 2 times 2 minus 7 times 4. Remember what this stands for. It stands for the modulus, which means whatever answer I get, it can never be negative, because obviously area and distance and certain things will never be negative. So that would be 4 minus 28, which is going to give me 1/2 of minus 24. Sorry. 1/2 of minus 24, which will become a plus 24 because it's the modulus, and therefore the area of this triangle is 12 units squared. Okay, so it's your turn now. I've given you the formula. You will now do for me, please, question 1 on page 278. You're going to do question 1 and question 2. So the first part, you'll see here one of the points is 0, 0, so it'll mean you won't need to move the triangle at all. And in the second part, I might get you to do is question 4, actually, because in that one, you will have to move the triangle and you'll have to do a translation. Okay, good luck everybody, and I'll see everybody in class.